Okay, this is a video that's going to review with you what a dot plot is. We're going to talk about mean, median, and mode all over again like you did last week. And then we're going to look at how distribution, shape, and spread can give you information that is outside what the measures of central tendency are. You ready? Ready to learn? Okay, so a dot plot is a way to represent the distribution of a data set. Sometimes it's called a line plot. Last year in 5th grade, you guys use line plots. So these are called dot plots. It's the same thing. I think you guys use X. We use dots for a dot plot. Hey, so this is a representation. This is a data set of hours spent on homework each week from some various class. So if you look, each one of these dots represents a student. So how many kids are in this class, or how many kids are represented by this data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 kids. 20 kids. Now, you should have at this time already looked at the information I gave you. So you're kind of looking at you're looking at the shape of this data, okay? So before we go into that, let's find the mean, median, and mode by looking at this data set, okay? So, mean. Think about how you find the mean. So what you're going to do is you're going to add up all the values in your data set and divide it by how many pieces of data are in the data set, in this case 20. So let's do this. Well, that's 0, 1, 2, 3, 4, 5. So that's 5. This is 8. 5 plus 8 is 13. 13 and 9 is 22. 22 and 16 would be 38, 48, and that would be 58, 57. Okay, so that would be 57, right? You added up all these points, or all those values, and you divide it by 20. Trusty calculator, because in math we always use good tools, right? All right, so we have 57 divided by 20. Whoops. 57 divided by 20 equals 2.85. Okay, so your average or your mean is 2.85 hours spent on homework each week. Now, let's find, all right, camera woman, let's find the median, okay? So I'm going to show you a fast and easy way that you don't have to write these numbers over. If you're given a data set, you're not just plain numbers, you just put those numbers in order and then find the middle, correct? Well, you can also, with a pencil, you can cross out like the smallest value and the largest value and keep going in toward the middle. But another way you could do this is to do what I'm doing. So I'm going to try to find the middle. So that's the smallest piece, biggest, and I'm going like this. Okay. And it's going to go, I'm going to try to go as fast as I possibly can on this beautiful Easter morning. Okay, so now I have 3, 3. Okay, so then I'm going to go here. I'm going to go here. Okay, I'm going to go here. This is when I want an assistant. What do you think? Should I have an assistant right now? Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hey. Okay, so then I have one here and then one here. All right. So I can now know that the median is 2.5, right? So I'm going to put that down. Put that number down. The median is 2.5 hours spent on homework each week. The mode, of course, is going to be the value that you see the most. So if I remove these little sheets of paper right here, I'm going to see, remember the word from your vocabulary, peak? The data peaks right here, 1, 2, 3, 4, 5. So the mode, of course, is the value you see the most, and that is 1. Now, all of this information is important, but oftentimes you normally pick one of these measures of central tendency to use. And I'm going to kind of tell you why. The mean and median, this is almost 3 and this is 2. What do you think is most representative? What is most typical in this data set? Well, it turns out median, the values of the numbers don't matter at all. This kid, if this kid right here was here instead, your median would still be 2.5. However, when you have an outlier, an outlier, in this case 9, it pulls that average up. That 9 is pulling that average, the mean up. So usually when you have an outlier like this one, you use the median, which is, you know, the middle. There you go. So median, mean, and median. When you have crazy outliers of course are data points that are extremely smaller or larger than the rest of the data set, you're probably going to stick with median. Come down here. All right, camera woman, can you see me down here? Can you? Camera woman, we good? Okay. If you were to look up on the internet right now, Wake County homes, the median value is 310,628. There's a reason that real estate agents use the median. They want you to buy in Wake County. They don't want that number necessarily high. The higher this number, the less people feel that they can afford to live in this awesome county of Wake County. So the reason they use the median or the middle value is because of this. So if you were to take a sample, a representative sample, like a small group representing all Wake County homes, if you were to pluck all those out of a hat in an unbiased manner, you're going to get homes that are like 250,000. You might have 280,000. You might have 315,000. You might have 500,000. Not unrealistic, correct? You might have 100,000. That might be a really small home, or it might be a condominium, something like that. But the reason they don't use mean is because there is somebody in Wake County probably selling their house for $35 million. When you have a big number like that, an outlier, similarly up here, this is one heck of an outlier. It's going to pull that measure. The mean is going to be much larger than this, and real estate agents want you to shop in Wake County. So that's why they use the median. Gotcha? Got it? Are we good right there? Now, y'all are like, Miss Rice, you made me read and watch these videos on the shape of data and all that kind of stuff. Probably going, oh, a lot of people, when they think of statistics, they think straight, mean, median. That's exactly where their mind goes. But we also have to look at the shape of the data. So, camera woman, if you can like zero in right here, I got 2 classes. All right, I got class A, 5th grade math scores. These are pretend EOG math scores. Usually I'm given percentiles, which is something completely different. We're gonna pretend they're percent correct. This is class B. Now, look up here. Y'all love that I still have my little stick here, don't you? I've got my mean at 80. This class has a mean of 79. About the same thing. The median is 80. The median is 80. 21 students, 21 students. So if you just think that mean and median are the only 2 things that you need to look at, you're like, okay, good. I saw my data, I'm going to walk away. But these are 2 totally different classes. Look at the shape of the data. This looks like that symmetrical distribution, that symmetrical, or some people call it normal. Your parents might know it as a bell curve. This is one way this information can be reflected. But if you look down here, this is a totally different class. Okay? This one, again, normal distribution, symmetrical. Your mean and your median and your mode are all going to be the same amount, right? But when you look down here, same data, or roughly the same data, but this is skewed to the left. So I'm going to just have you think for just a second. What are the implications for teaching this class versus this class? What might I have to do differently here? Okay, you didn't pause it, did you? All right, good. All right, just sorry guys, my camera person is just an amazing person that is helping me out here. All right, what are those implications? Let's look. All right, look at my peak, my mode right here is at 100, okay? So I have 7 students who might need enrichment. I don't have as many kids that need enrichment here, okay? Then I have someone all the way down here. Now I would investigate this particular student and look to see what this one piece of data would reflect. I wouldn't just make any assumption based on just this one score. So I'm going to look at that kid's 4th grade and the 3rd grade scores. I'm going to look at ELA scores. I'm going to look at grades. Maybe they misaligned when they were bubbling in their 5th grade EOG. But there's a gap right here. Okay? And then this is skewed. Let's see if Miss Rice can spell skewed left. You always talk about it in terms of what they call the tail. This class has more spread. It has more variability in its data set. This class might be a little bit more difficult to teach. I have some kids at this bottom end who might need more support. I also have kids that I need to enrich, more so than here, okay? So just because these scores are similar does not mean that I got to teach these classes the same. So implications for teaching. One class might need more enrichment, like I said, misspelled, Miss Rice. Enrichment, okay? There might need more support for some students. When you look at EOG scores, this is still a 3 or a 4 right here. These kids understand. The content from 5th grade, whereas this kid certainly does not. These might need a little extra help as well. More support, more enrichment. I also might be asking for an intervention. And another teacher in the classroom for support. Intervention support. Okay. So these are some of the different reasons. Let me go back. These are some things I might need to do based on this data. All right? You guys have a good week, and I'll hopefully see you sometime.